Well spacing optimization using Ruby. Operators drill new development wells in order to sustain commercial production from petroleum reservoirs. These wells must be strategically located within the reservoir, otherwise their performance may be severely impacted by interference from existing wells. The objective of this video is to demonstrate well spacing optimization in unconventional reservoirs using Ruby. This Ruby file contains a representative multifractured horizontal well which has been identified from a prior field performance analysis. It is called the parent well. New locations have also been proposed for 3 new child wells targeted to come on stream 2 years after the parent well. Click on the Wells button to launch the Wells dialog. These are the 3 new wells proposed. To copy the parent well geometry to the child wells, select the parent well in the From field and select all child wells in the To field. Ensure the Geometry and Perforations checkbox is toggled on, then click on the Copy button. This duplicates the exact same geometry and completion of the parent well for the child wells. Select the Schedule tab and observe that the child wells come on stream 2 years behind the parent well with the same operating strategy. Click OK to exit the Wells dialog. Observe that the child well geometry and completion are now identical to that of the parent well. The goal of the simulation exercise, however, is to optimize both the parent well spacing and the child well spacing for maximized recovery. Proceed to the Run tab where the simulation is going to be run. Before running the simulation, have a look at the well's completion. Moving the slider reduces reservoir opacity, and the lateral section of the wells and their hydraulic fractures become visible. The reservoir has 3 layers, and the wells are completed within the top layer. Now run the simulation. Upon completion of the simulation run, maximize the well results plot and select only cumulative production and bottom hole pressure for each well in the Gauge Results dialog. To observe the 2-year gap between the parent well and the start of the child well's production. The cumulative production plot also shows that child 1 sees the most impact on production because it is closest to the parent well. Maximize the 3D plot and select Pressure in the Property field to observe the pressure field in the reservoir. Play back the pressure fields. Observe the propagation of pressure pulse in the reservoir through time and the eventual interference between the wells. Global and layer production can also be viewed on the global results plot by selecting the required results. The steps shown so far focus on one well spacing scenario. Sensitivity can be performed on parent-child and child-child well spacings, comparing the EUR of each case. With this information on EURs versus spacing, a surface plot can be generated and used to determine the well spacing which maximizes recovery. In addition to optimizing lateral well spacing, Ruby can also be used to investigate optimum vertical well spacing or a combination of both. 3 additional child wells have been added, and their geometry and completion duplicated from the parent well. Click on Wells button and observe in the Schedule tab that the new child wells come on stream 2 years after the first ones and 4 years behind the parent well. Double-click on one of the new wells to launch the Wells dialog. Switch View to Cross-Section. Observe that the new child wells are completed in the middle layer of the reservoir. Switch to the Run tab. Maximize the 3D plot. Use the slider to reduce the reservoir opacity. Observe that the wells are staggered using a wine rack pattern. Play back the simulation to see the evolution of the pressure fields along the parent and child wells. Sensitivities can be run to record different combinations of well spacing and the resulting recovery. With this information, an optimum spacing can be determined. This concludes this video on well spacing optimization using Ruby.